area here should have the positive potential as well. So like the area between the curves should have, I think, maybe the same signs as long as you have a equipotential line at
Oh,
0.
okay, I'm with you.
So my interpretation of this picture is maybe the only negative potential areas are around negative Q.
Yeah.
This area, I'll point at it inside the area. But I'm not sure.
Oh, we think that B has positive potential, right? Because
I think so.
That's these points here for me.
right.
I do like kind of trying to do like an intermediate value type of thing. Like showing it goes like, is there some kind of sign change? I just don't. Like we found the potential at like 3-0 and 4-0. Can we expect to find different signs and that will prove it?
It would be interesting to see.
Yeah, I guess let's try it. I guess I'll do it on the right here. Uh, 3,0. V here is Q over 4 pi epsilon naught. I guess for the positive charges, we have a triangle. The bottom is 3L. I guess 3L comma 0 is what I'm calculating.
We don't have to do 3 exactly. You can do anything between like 2 and 3.5. So if there's a value that works easier, use it.
I guess that's true. They can make it 2L. Lower numbers. So the distance for the what?
That might be predicated on the hypothesis that these signs don't change, but we'll see what happens.
Yeah, I guess we might end up getting the same sign, but so the bottom of the triangle is 2L. If I'm doing the top positive charge is what I'm looking at. 2L and 2L. 2 times 2 for the positive charge.
2 root 2, right?
Yeah, 2 root 2L. I was gonna do it out. But yeah, we have. Oh wait. No, I can't visualize this. It's 2L and 2L. Like that. Oh, so it is just 2L. Okay, you're right. Hopeless. Sorry.
I thought it was root 2. I forget which one we were even looking at.
Oh.
Right, I was thinking about the wrong charges. That's for the next one. I was working ahead. I planned it out the whole time.
The first positive charge is just distance L away. The second negative charge is 2L. No, L plus 2L. No.
Actually, I'm a little confused now. The first term comes from which points here? We're working with this point and these ones?
Yeah, I was trying to do both both the positive charges at once with that first term. I see Stuki just flip
Okay.
my signs, which
Well, I think that has a distance 2, does it not? Between 2 comma 0 and the 2q point.
wait, if it's a oh, what did I do wrong then? 2L squared. Oh, because I didn't add them. Yeah, it is 2 root 2L. Thank you, Phobos.
No problem.
Right, it's root 8, not root 4. That distance is L. Okay, L plus 2L is 3L for the farther away negative charge. That's my claim. Jed, I'm glad that you appreciate the phrase predicated upon the hypothesis. So 4 over 2 root 2 minus 1 minus 1/3. What am I? Oh yeah, okay, so this is 0.08 positive. What we care about.
Kind of makes sense that it's getting close to 0 as well, because it's kind of close. That point 2L comma 0 is pretty close to the 0 equipotential line.
True. Thank you, Stuki, for getting started on that 4 out. Does that look like a negative number?
It does not.
Ah, dreams are shattered.
That's what we wanted, though. We wanted it to be positive. The idea, I think, was that on the left and right side of the intersection, that they would have the same sign. But then the
Yeah.
question is about north-south now. Does it have negative sign? I'm not so sure anymore because, like, at the point, I looked at the answer, so I know what it is for B, the
Oh.
potential curve. But then, like, value should be close to that value, which is positive, around that point. So then I would have a hard time believing it would change sign when you go north or south. Now I do. I've changed my mind.
So, are you say did you say it's positive also for like the north and south?
I think it might be because like imagine perturbing the distance a little bit in the denominators on the second calculation. Or like if we did a calculation for the point at 3.44 comma 0. So that'll be some positive number. And then perturbing the distance like up just a little bit, finding the potential just north a tiny little bit should be close to the same value, which should still be positive.
It's fair.
Would that mean it's
Mm.
positive potential in that little area between the origin and the northernmost 2Q charge?
Mm.
Yeah.
Yeah.
Yeah, that makes sense. Like, because we are a little bit close to that positive 2Q charge, so I think we would have a little bit of positive work to be done there. Hmm. Do you guys see how they make the argument for like this B crossing the x-axis part?
I haven't. I just looked
Okay.
at the first numbers.
Hmm.
I got it pulled up. I can peek down looking at these answers.
I think I'd be okay with it. Does anyone want to like keep thinking about it?
I think it has to be.
What?
I was going to say, I think it has to have something to do with the fact that it's a potential surface that's somehow intersecting itself at an angle, right? There has to be something. There has to be something mathematically interesting about that property.
I think at the origin when it crosses, the electric field is 0.
Hmm.
So like,
Oh,
is there anything about how if the lines cross like that, does that imply how the electric field is at all?
Oh, maybe that's what it is.
huh.
Yeah, could we convince ourselves that there should be a point on the x-axis out there where the electric field goes to 0? It
I'm
feels like it.
convinced.
Yeah, it seems reasonable.
Okay, so let's say we knew E was 0 at that point. How do we use that to find the potential? Okay, maybe that's a really good idea.
Well, is that interpretation of the behavior of equipotential lines accurate? I did not read this.
I read it and I'm like really lost.
I
I was hoping I wouldn't quite be so lost, but
Chapter 2 makes chapter 1 look like ...
Yeah, this is a 1-star problem too.
yeah, I know. It doesn't build the confidence, does it?
You know, we were
Okay.
saying that about the first problems of the first chapter. We're going to conquer these, all of us.
Yeah, we'll get it.
Mhm.
If the electric field is 0, does that say anything about potential? I don't think it does, necessarily.
Yeah, I'm thinking about like how the equipotential and the field are always perpendicular, and you can't really get there is no perpendicular point. I guess you can do it individually for each like part of that intersection, but I feel like that'd be like a contradiction where exactly at that point you can't have just one perpendicular thing, right?
Yeah. Unless it's 0. I think
If it was
Oh yeah.
so what happens in math, when you have a saddle point to a surface? So if it's a function of 2 variables and we have a saddle point, what happens to like the gradient at the saddle point? It would
The
feel
gradient is
like it
0,
could have.
right?
I think maybe
is it?
some of the coordinates reach 0 and then others might not. Or does a saddle point require all the coordinates slopes to hit 0 at the same time? I think probably it does.
Yeah, I think any critical point has all 0 for the gradient. Okay, yeah. Paul says that the gradient is 0 at a critical point, and it thinks that points count as that. Could we get, like, would it be that painful to get the gradient, or like, could we get the field just on the x-axis and find where that's 0?
I think that's definitely possible.
Hmm.
Or even if we set up an equation to find what's the field at that point, we can find it that way too. Which I think would be the same. Kind of. Same idea.
Yeah. Okay, how complicated would this be? I'm going, I guess, even to the right of our 2L and 4L calculations. We want to calculate a point x comma 0. We can just let x be greater than 0.
I mean, it's a bit of a mess, but it's calculable.
4 pi epsilon naught. So the positive charges they're positive 2, and the distance is, well, 2 times 2. Root x squared plus 2l squared. 4l squared, I guess, if I'm not writing parentheses.
Why don't you
Minus.
just like, let's not put the L in there. Is that all right? We can just think of X as a scaled by L.
Yeah, I think
Okay.
that would simplify.
Oh wait, that's not right. What I just did. There we go.
And for electric field, is it square root in the denominator, or is that r squared law?
Oh, I'm doing. Yeah, good point.
Good catch. Yeah.
Hell yes. Catching.
The x minus 1 is for the closer negative charge. And the farther one, I guess, would be x minus 3?
X plus 3? X plus 1.
Oh,
Plus 1.
plus 1. Yeah, makes more sense. Where minus 3 came from. Okay. And then my plan was to, I guess, take the derivative.
And square those denominators.
True.
And then I think you only really need to think about the numerator that you'd end up with and when it's 0. Because we're looking for
Right. But it's not.
0.
Is being undefined important? At plus or minus 1? I guess that's where our charges are. That's not important.
Just ignore those points.
Oh, we need a cosine theta, don't we? Or do we? On the positive
I think
charges?
for the electric
For the
field,
positive.
do we?
Oh, yeah, for the ones on the y-axis, you do.
And cosine theta, can we
Isn't the
parameterize that?
cosine theta baked into the distance calculation?
Yeah, but we're not computing E. We're computing E sub x. So the cosine theta is there to extract the x component.
Yes. Thank you.
For sure.
Okay, make sure my definition of cosine. If we're defining theta as like from our x point up to the positive charge, I think I'm good. All right, and that seems like something where we weren't getting the numerator 0 for anywhere with the initial version. I don't know if this is much better though. Well, I guess we need to get a complementary to know. Ugh.
I mean,
like the
it's better
first
in
one.
the sense that I believe that this number sucks.
Yeah.
4 sucks. So like,
It's probably overkill for what they're intending us to do for a 1-star problem. But I was thinking like the derivative will be informative. So that would be the potential, I think.
right, but we want to set this equal to 0. We want to figure out the x value for that's 0. That was the game here.
Just as a little check, right? We can plug in x equals 0 to this expression we got because we want it to be 0 at the origin as well, I think.
Yeah,
And
Sure.
I'm mentally plugging in x equals 0, and I'm not seeing the 0 I'm hoping for.
I think it's +1 -1.
Isn't it
Oh,
-2?
it gets squared. You're right. Yeah, I get -2. Hmm.
Wait, but is that a oh yeah, because you have this self intersection. Okay, yeah.
Yeah, and just by the symmetry of the problem, you can kind of look at it and see that the electric field has to be 0 at the origin.
True. Yeah.
I mean, I know this function is defined at x equals 0, but I wonder, is it supposed to actually be 0 or just something weird and undefined? I don't know how to think about it.
It's at 3.44, I see.
Ah, that's
Oh, there's a 0
that's
there.
encouraging.
I did fix
That's
x to be
encouraging.
greater than 0. If I was more careful with or if we made a more general definition of x, because like I was dropping off absolute value bars and stuff like that, that might be why.
It doesn't seem to go to 0 around 0. No, wait, the scale's cut off. Never mind. Oh, yeah, it's axis.
Yeah, Don, that's right. We need x is bigger than 1 to work, because otherwise this
Oh, I see.
the other direction.
Oh, I see.
Yeah, we get
Based on the
assigned
way
with
we
the
constructed
cosine.
it. Okay. All right. My bad.
Yeah. I didn't think about that either, though. But and yeah, x greater than 1 is probably more accurate here. So yeah, there's a
No, that's really
careful
cool.
stuff.
That's cool.
Okay.
I don't quite follow. Can you explain that again, the signs?
Yeah, so this is again like a cosine data thing here. So but it's I mean, it's different.
Yes. Okay.
But yeah, if x is bigger than 1, then both of the charges point in the same direction.
Yeah, nice. So one of those minuses becomes a plus, doesn't it? When we're between the two negative charges on the x-axis, one of those minuses in our expression turns into a plus, and so we do get 0 at the origin, like we want.
Right.
I think, right? Is that right? Is that how it works?
I think so.
Yeah, I think like I don't know how the positive term would change, but it wouldn't matter because it would go to 0 anyway.
I'm still skeptical. I said I get it, but I'm still skeptical.
I'm curious about the derivative of this thing still.
I think it's good to be skeptical. I'm pretty skeptical too.
This whole book is suspect.
Can't trust it. Not even Wolfram wants to graph the derivative. Oh, here we go. I guess we only care about where x is greater than 1. Does that really mean anything special? Wait, why does this... What? These are different depending on the scale.
I think wait, what? Really?
Oh wait. Oh,
Oh, it's really zoomed in on the
it's just
y-axis
it's super
on the
zoomed in
bottom,
there. Okay. Yeah.
but it does appear to cross. Does it tell you where it crosses on the bottom picture? Like if you have your mouse over top of it?
4.9. Huh.
Also, what is the physical interpretation of the derivative of the
Oh.
electric field?
I was kind of naively applying the gradient. Oh, it's a gradient of phi. I have this backwards. We need to integrate the field, I guess. Wait, we get to. If we want to go from field to phi.
Well, I mean, if our idea is right, and if we found the x coordinate, then we can just go back to the first method we were using.
Oh yeah. Okay, you would
I
need
think
to
that's right,
integrate.
right? So that, yeah, that chapter summary you've got on screen right now. So equation 2,102.
2,
So it tells us
yeah.
the electric field is the negative gradient of the potential. So doesn't that mean, I'm trying to think again of the significance of the fact that we saw on the equipotential lines, there were points where it would intersect itself at an angle, right? Does that mean that the electric field always has to be 0 at a point like that? Because I'm thinking that means, if I think of it like a 3D graph, that there's a saddle point there, and it's kind of, the potential is decreasing one way, but increasing at right angles to that, right? So
Yeah,
if it's a saddle point.
I think I agree with that. And equation 2,102.
Yeah, we've just found a critical point for phi is what this is, or at least potentially we can only check the x component. Also, I'm interpreting this backwards again. But if E is the gradient and we found a 0 for that, I think it's some kind of potential critical point for phi. We'd have checked the y component too, I guess, but.
Yeah.
Symmetry.
Okay.
Use the symmetry.
No, I do want to check the answer, like, for this one, because I feel like they probably just solved it in one sentence. Whereas we have this, like, whole discussion and calculations. But
Well,
I
if we
don't know, before I
actually
check it,
plugged
is there
in-
anything? Or what?
If we actually plugged in for the electric field calculation of 3.44, we would get 0, correct? I was seeing that in that graph. So we
Yeah.
all agree that the field is 0 at that point.
Yeah,
So-
we agree. By Wolfram, we got that.
Proof by
And then
Wolfram.
is there any concept of a multivariable antiderivative or anti-gradient? Is that a thing?
I think you have options for how you interpret it. But, like, these two equations undo each other. I don't know if someone has a better, like, response, but, like... Oh, yeah, you can definitely... If you have a gradient, you can definitely find the original by integration. Usually you have to do 2 or 3 separate ones, depending on how many variables you have.
Right, okay. I don't think that helps, but
Yeah, but I guess as long as you have, like, one piece of information, you can get all the others, I guess, is kind of the point of the chapter anyway. I'm about to skip to the back of the book.
Were there any more parts to the question, or I think we finished it then.
Good question.
Oh, they wanted us to sketch some intermediate equipotentials.
I would think that they're just more or less going to follow the form of the potentials that we have shown.
Yeah.
I don't think there's anything too special there.
Would there be, okay, how about this for a question then? Would there be any other curves that would intersect themselves like the ones they gave us?
I should be able to make a simulation picture of that setup with the electric
Ooh.
field strength.
Nice.
Let me do that.
Be interesting.
If I can even remember where I did that. Where did I do that? You know where my files are, right, Don? Fembox? Anyone?
I didn't realize it was my turn to keep track of that, but no, I didn't.
Yeah, it was your turn.
I assume we've shown that there wouldn't be any more for x greater than 0 with the little field calculation that we did. It does cross the x-axis more, these equal potential lines, but it doesn't intersect itself.
Is there a quick way to look at the picture and convince ourselves that there aren't any more points in space where the electric field would be 0? Or at least in this plane of the picture.
I guess I mean I think we'd have the field being 0 on each of the 4 like axes somewhere.
Yeah. Did they say how do we interpret this as a oh, that's X and Y. Okay, so Z is coming straight out. So what about along the Z axis? There's not going to be any points on the Z axis where E is 0.
Ooh. Actually, I thought the Y axis, I don't think there are. Z, I think it does, because the negative Q's are pretty close to the origin, so they might outweigh the 2 Q's. On the y-axis, I think the 2 Q's are kind of taking over. Well, maybe inside. I don't know. I just don't know.
Just one moment. I'm almost done with my picture.
No worries.
Just adjust in bounds is all. Living a bounds life. All right, let me find a picture. And paste a picture.
Radius increase less.
All right, I have pasted a picture.
Nice.
It's hard to see the 0 electric field in the center, but it's there. You can trust me on that. I was expanding the bounds of the picture to hopefully find a 0 potential in the y-axis, but I didn't see one.
I'm not sure there would be. I'm still not sure what to think about that, though.
So the dark region, it's the 0 electric field. That should be at the 3.44. The scale from the center to the edge is 4 units. 4
good.
L's. So that's about, wait, what was it? 8 L's. So at half of that's about 4. And there's the one in the middle.
Nice.
Awesome.
Look at all these charges.
I really like these pictures you make. It's, I don't know. Something about them is, it appeals to me. I think it looks like an old school video game picture or something.
play a game in there. Turn this into a 3-dimensional landscape that you can do stuff on, like sled.
Yeah,
Not to get
there has to be a
anybody too
game in
deep.
there.
Has anyone ever played the game Magic Carpet?
No.
No.
Oh, I love that game. It was an old 90s game. The world was basically like a bump map that you flew around in.
Oh. That's cool.
Actually, a question about this picture you made, Phobos. So all 4 charges are kind of green, right? So
Yes.
does your software can it distinguish between like coloring positive versus negative like point charges?
No, it can't. I haven't thought about how to do that kind of color scaling. It might be possible,
Yeah.
but I have to think about it. The issue is this is colored based on the total or magnitude of the field strength.
Okay. Yep.
You know, for simplicity, my specialty.
I don't blame you.
Yeah, I don't know how I'd figure out that like scaling if you have 2 different things to slide.
And another issue with these I would like to think about some more is field lines and such. Or at least direction vectors for which way the field's pointing. I feel like that would illuminate in the same way as a color encoding.
Mhm. It is kind of neat how quickly it drops off as well. I mean, I guess it's hard to get like that good a direction of like distance, but like they're talking in the dipole section about how the field from a dipole drops off like r cubed or something like even quicker because they kind of cancel each other. And I think it's like not as strong here, but it's kind of like similarly dropping off quicker than we might otherwise see if they're all the same like sign. But I still want to like hey Spaceberry. Oh,
That was a good problem.
yeah.
I'm glad we started with that one. It did feel kind of hard though.
Yeah, I still want to bring up the solution because there must be a simpler way to have figured the same thing out. The general potential. Oh, I mean they're doing some complicated. They get the question for phi in general.
Overachievers, Don.
Yeah.
Overachievers.
Whoa. They have a more complete. Huh. Aerogent Logician, thanks for the follow. Welcome in. Okay, at locations where equipotentials intersect, the slope of phi is 0 in 2 independent directions. So phi must locally be a flat plane. The intersection is saddle point. What you said. Since E is the negative gradient of phi, this implies E equals 0 where the curves intersect. Okay, then the second paragraph is where they find the 3.44 part. Oh, hey. This is a 1-star problem? We did it the intended way, I guess.
I mean, pretty close.
So they said for that final part, they said Find the total EX component due to the 4 charges at points on the x-axis, and then demand that EX equals 0, which can be solved numerically. So does that mean we actually couldn't have solved that? We couldn't have found that 3.44 without Wolfram? I had a feeling maybe we could do that on our own, but maybe not.
Well, I think we would end up with a 3/2 power in the numerator.
Yeah,
Would complicate things.
yeah. What's this
Um,
final thing they said? You can set y equals 0.
I think the thing they got above, the general
Oh, okay, okay.
equation 12.70. Oh god. Okay, yeah, 12.70 is the general x and y point.
Yeah, gotcha, okay.
You were at the stage of understanding vector calculus and you got a job, forgot the universal matrices, reached your peak of learning. That's fair. We're having our vector calculus knowledge tested here too.
Let me just say, I'm so glad that I spent a week doing review on divergence, gradients, and curl and stuff. Absolutely necessary for this.
Oh yeah, I gotta brush all that up too. I've been, one thing I've never really understood is divergence and curl. I've never really got my head around like, what is this really, how does this really work? What does it tell me? I'm hoping that if I study this chapter a little bit and Appendix F, that I'll be able to put some of those ideas together and they'll sit in my head a little better. And it would help if I read the end of the chapter too. I think I haven't quite finished.
I think
I got
between
to
us
this.
all, we might have read the whole chapter.
Yeah, piece it all together.
Yeah, maybe all together, I think we've read the whole chapter.
I did
y'all are
quite like
carrying
their.
me, though.
Oh, what?
You all are carrying me though.
I mean, you're still helping. But their explanation for divergence, I liked. It was apparently they want to derive it in Cartesian coordinates like actually as part of the chapter, but they kind of describe it as just the flux, the net flux into or out of a unit volume for any little piece of volume you want to choose. But yeah, I read it and I felt like I understood it as I was reading it, but I probably couldn't like repeat everything back to you or like construct the argument again for myself.
I'm assuming a lot of people who study from this text are in a course as well with, actual directed lectures and such.
Yeah. I guess should we choose another one here?
Sure.
So I did call out 3, 4, and 5. I don't want to get like just like a different theme though, because I think these are gonna be similarly like discrete charges. Talk about potential.
Is there a one-star dipole problem?
Ooh, let's see. Shell field, that's probably not dipole. Phi from integration, effect shell. I feel like I chose a dipole. I had to have chosen something with dipoles, right? Okay, one-star dipole, 2.15.
Yes.
Let me get a screenshot, get it in Discord.
Hold on, everyone. I'm having a dipole moment. And here I am, just hoping to get away with pronouncing it dipple sometime.
Dipple. I don't know why that makes you laugh so much, but like...
Right? I'm cracking
Dipple.
up over here.
Oh shoot. Discord's being weird for me. I gotta leave and rejoin the call quick.
But firstly, what is a dipole moment?
I think it's the charge times the distance between the charges. I think.
Right. And they've
So
combined
if-
it into one moment because it's kind of equivalent to talk about like a 10 times charge, 10 times stronger charge versus like 1/10 of the distance or something. Like that's why they care about the product, I think. Or they only care about the product. Okay, I got 15 pasted in here, like just a little bit below where we were working. Hey,
So
Herbot. Sorry.
a dipole moment is measured in coulombs times meters.
What is the dipole moment of the system? Shit. Now, how do you get the dipole moment again?
I was going to say it would just be twice the moment of one of them, but I don't think it is if they're at right angles to each other.
Yeah, it'd be neat if we just add their two moments together, but you're right. I don't know if there's a cancellation that might happen instead. So the way they found the dipole moment, just for a basic dipole, is they found it for just like an arbitrary point that's relatively far away. And they end up with a factor of Q times L, and they define that to be the dipole moment. For just two charges, like a basic dipole. And you end up with like QL squared over R squared as a dipole potential if you have more things potentially. I think we have to do some calculations, just like some trig calculations with I don't know if it's gonna be potential or field, or if either works. Always central. Okay, I mean, I wonder if there's a shortcut here that I'm missing, but
And if you do set up an equation for the potential for this, would you do it in spherical coordinates as well? Or no, I guess this one's circular coordinates. It's two-dimensional. In the example from the chapter.
yeah, I think they describe it as like spherical, but in this problem it boils down to regular polar. anyway.
That's the word.
Yeah, I think they literally just calculate the potential for each of these charges individually and see what factor QL you end up with. But they use an approximation to simplify the distances of these lines. Because we're far enough away, they're basically parallel. That's what the book said. Which I feel like it's not hard to just use the law of cosines either, but... yeah, each distance will be R1, and I guess the angle down from the vertical axis will be like theta 1. That's a Q, not a theta. Actually, what would it be for these charges that are offset? Would it be like that angle there? I guess it would be. Okay. I feel like there should be something easier though. Like if they're perpendicular, like we should be able to use the normal dipole moment for just two charges and combine them in some kind of smart way.
Yeah, the cosine theta for one dipole, would it be sine theta for the other dipole? No, wait.
Ooh.
Or is it cosine of theta plus 90? Is that how this works? Because it's kind of like we're rotating at 90 degrees. The second one, 90 degrees.
Why does the reference point in red have to be outside the points? Could it be in the center somehow? Does that simplify anything?
I put it relatively far away because that's what the book did, so they can make a nice approximation. I think you could... I don't know if it gives you anything simpler, but you could very well choose like a point inside as your reference point. And law of cosine should take care of things if you did it exactly.
What about literally the origin? And then that point is like equidistant from all the charges. Would that simplify stuff?
Mm-hmm. I'm not sure, to be honest. Because I need to look back at the book, I guess.
Don, you gotta exhaust all your options before you start.
I'm not looking at the
Or
answer
at
key,
least
but...
read the first sentence. Oh,
Yeah.
okay. I thought you were flipping to the back already.
No.
Don, no, say it ain't so.
So I always thought that dipole moment was just Q times L, but I guess that's only if you have a single dipole, right? I mean, if you have a system like we do made up of more than one, then how do you define the dipole moment for our configuration? Would it just be so?
Is it some sort of additive rule or linear rule? So I know
I got a feeling it's going to depend on the angle between the two. I'm just thinking it's going to depend on the angle. I'm looking at equation 235 in the chapter, which is the one Don had on screen a minute ago.
I brought it back up.
And it said,
go on.
It said the potential was Q times L times cosine theta. Oh yeah, here it is on the screen. So what's different? So if we consider that point a long way away from our configuration, right? The Q, the L, the R squared, all that should be more or less the same, shouldn't it, for both dipoles? It seems like the only thing that's changing is the angle theta. The one is going to be, trying to think in my head, is it, what's just theta plus 90 or minus 90? It would be something like that, right?
What is
It's an
theta?
arbitrary point. I don't know if there would be that clean of relation between like the two positives.
I think theta was a measure of the angle from the center of the dipole to our red point that's a long, long way away.
Suki, were
But
you going
but
to
it's a
say? Oh. Um, I'm kind of wondering if the choice of reference point makes a difference. I feel like I chose this reference point that's like closest to the two positives, but I wonder if it would change if I chose a point that's like closer to a positive and a negative, or two negatives, like if our quadrant matters. Because maybe it is 2QL, but we get some kind of maybe extra thing that we need to add on to that depending on what quadrant we're in, because I don't think that was as much of a worry for just a regular dipole.
I think in the book he'd made the choice on the side of the positive one, but I kind of felt like it didn't really matter. But cosine, all students take calculus.
I think for that one, they're actually considering a point not in the plane with the two lines. Or in a plane with both those charges, but like not the plane, not the XY plane like we have. So figure 2.15, I think, is a diagram of this setup from the equation we were talking about. And notice how the reference point R, see, appear to me, that looks like it's in the Z direction. Or am I misreading this picture?
It's not, no, it's not in the Z direction. It's that whole figure 215 is in the XY plane.
It's in the XY, okay.
Yeah, the dotted line stuff is because of their like geometry tricks they're using to get the distance. If that's what was throwing you off, maybe.
Yeah, it looked like a 3D picture.
It does a little bit, I can see that now.
But the idea, does the idea make sense? I don't know anything about the dipoles, but would it make sense to look at a reference point like offset in the z-axis for the problem that we're working on?
I think the thing that's confusing me is they just say that they're defining QL as a dipole moment. But in my reading of it, now that, you know, because it's make me think about it, I don't know exactly what other, like, in other situations, like, where's your dipole moment, I guess?
Well, it turned out to be QL for that example that they did in the chapter, right? But I guess they're saying it's just the number in front of the cosine theta, right? If we could write it as something times cosine theta over 4 pi epsilon naught r squared, then that something would be the dipole moment.
I guess so. Moments distribution. I think my bet is that they just want us to figure out this angular dependency stuff, and I don't see them give us some kind of like formula to just work it out. They talk about keeping terms of a Taylor series, but I don't think that's going to help us here. Like different terms of Taylor series mean different things, but yeah. I'm a little bit weirded out how we think about these angles, though. I see this, that someone drew like, I guess like data plus pi over 2 for this charge on the left, which was kind of confusing me on how we would deal with these two like horizontal charges, I guess, and their angles. Two, three, four, yes. Q1, R1. K, Q4, R4. Is how the book's set up for just a normal dipole, but with only two terms, we only had two charges. And now we need to express R1 and R2. Well, actually, we're taking them all as just Q. I don't need to do subscripts on those.
Right.
And I don't know if we want to try to figure out a nice approximation like they did for these. Oh, that's not R4. For these R values, or if we just want to deal with the law of cosines. I guess if we're taking like this green dotted line as our like good R that we're going to put everything in terms of.
Yeah, I'm happy to just use the geometry approximation that they do.
Okay. I need to work back through the geometry approximation because it was kind of like weird to me. It took the angles theta, it took them as parallel lines for far enough. Wait, does that hold when we have this horizontal thing?
It's a
I
different
guess it's
angle.
really far. Oh, it is? Okay. Hey, water eater. It may not look like it, but I promise this is physics. With the current view I have up. I keep writing Q, I don't know why. I really don't know if we're supposed to consider these all as parallel, but
Yeah,
reading they might not be? Or yes? Okay.
yeah.
And then I guess We can use the same approximation for the vertical charges that they do without thinking too hard about it, I think.
Mhm.
Which means R1 is R minus L cosine theta over 2. Because we're taking the total distance R and subtracting off just the little dotted part. Which I think I can believe is L cosine theta over 2.
I think your dotted line was supposed to go through the origin there.
Oh, it is, yeah. And that makes it a bit more clear, I think. And then R3 is going to be the same thing, but plus L cosine theta over 2. Because that one has some extra distance. Oh, I was trying to draw them so they're offset, but if these are parallel lines and they're both L away from the, or I guess L over 2 away from the origin, the horizontal, like this one on the left, should eventually be the same as the line from the top charge. And the bottom charge should go into the line from the right charge.
No, that's only
No?
true if theta is 5.
Okay.
All angles are 45-degree angles. So
Yeah, your theta was 45. then-
Oh, true, true. Okay.
my high school physics teacher, and this was a big pet peeve of his, says everybody draws every angle as 45 degrees.
I was trying to avoid that, but I still couldn't help it, I guess.
It's hard, yeah.
Um, yeah, we can get the length of the hypotenuse and just add it to R? Or maybe, I think you're going somewhere else with this.
Am I doing that right?
Is that extra distance? Over 2 cosine. Where is it pi over 2 minus theta? I'm trying to. Oh, because this other angle's theta, right?
Yeah.
Okay. That seems reasonable, yeah. So that's, I guess for R4, we'd have R plus the factor you just got.
I'm not sure does look like sine. Yeah.
Hmm. And it's hard to tell, like, what's my bad drawing versus, like... So it maybe looks a little bit short to me now, but that's probably just my drawing skills. No, that's probably the part that we want. I don't know.
What's up?
I was thinking, like, it seems a little bit like if you were to take your green line, you just got the factor 4, and like extend it from here, it wouldn't reach all the way up. Is that good or bad? Because I was thinking I want to find like the distance here.
Ah, I see. No, yeah, those are unrelated.
Okay.
Because the real stuff is this, right? And the angle is like this.
One of these points is R2.
The
What
right
are the
one.
points?
We haven't.
The rightmost.
Yeah.
Okay.
Hmm. So yeah, I can leave it. I guess I was having a hard time, like, I guess, visualizing it, but I would definitely go with your idea over mine. For R2, it'd be nice if we just subtract off the same thing. I don't know.
It should be.
Okay.
Yeah.
Yeah, I guess because it's symmetric.
You do need L over 2 in those.
Ooh.
So
Good catch. I just miscopied what Stuki wrote. Okay, and then from this point, they plug these R's in and they use an approximation. Okay, so I'm going to come back over to the left side of the whiteboard. Factor a KQ out.
Do you say they plug them into something? Or they
Uh,
just add them together?
like add all these R1s, R2s together?
I'm just asking what you're doing. You say you're
Oh.
plugging it into something. I'm curious what the something is.
Sorry, yeah, so I'm just kind of blindly copying what the book did to get the dipole moment. So we're using the same kind of like approximation technique, and we're plugging into the equation for electric potential V, and hopefully it spits out something that we can interpret as a dipole moment. So I went back over to the left side where I wrote like an initial equation for phi with R1, R2, R3, R4, and went over to the right side to figure out what those R's should be.
Okay, thank you.
No worries. So R minus L cosine theta over 2 plus 1 over R2 is R minus L cosine pi over 2 minus theta over, oops, not that over. Minus 1 over R plus L cosine theta 2 over R plus L cosine pi over 2 minus theta over 2. And from that point, they say that use the approximation that 1 plus 1 over 1 plus or minus epsilon is about 1 minus or plus epsilon. That's not epsilon.
Is that
That's
something they use? Because me looking at equation 2.35, it looks kind of like they found common denominators and then dropped the common denominators.
Yeah, it does look like that. I think that might be a
Oh no, wait,
coincidence.
they say it right up above.
yeah.
Yeah.
So, hey Viv, haven't had to hear that since 11th grade. Wait, they did get an extra factor of r outside, didn't they? Oh, they factored an r out from the denominators. That seems weird. Oh, to get it, I get it. Otherwise, we can't use the approximation. Okay. Because it's a 1 in the denominator, so I guess we're factoring the r out. Okay, so it's 1 plus L cosine theta over 2r. If I don't have to add those r's, I know I'm going to forget it for at least one of these. L cosine pi over 2 minus theta over 2r. To r minus L cosine pi over 2 minus theta over 2r. I remember them. Okay. I guess we're just combining stuff now. The ones I'll cancel.
Oh, wait a second.
And we get plus L cosine theta over 2r plus L cosine theta over 2r, which is just L cosine theta over r. And we get a plus and plus for the pi over 2 minus theta. Isn't that sine? Cosine pi over 2 minus theta.
Yeah.
You can just like leave it as it, I guess, for now, but maybe we'll change it in the next step.
I've been sitting here trying to think about how do we deal with cosine and sine, but aren't there formulas? Like if you got cosine theta plus sine theta, isn't there a way to write it as cosine of, there's a phase shift, right? It's like there's a way to add these waves, right? When they have the same frequency, like,
Yeah.
yeah, that's what we got to do here. That's what we got to do. We got to take cosine theta plus sine theta, and we got to write it as cosine of theta plus pi over 4, or whatever it is, divided by the square root of the amplitude, or whatever. There's a way to do this. There's a way to do it. I've got to remember how to do it.
There's a way to combine these into one factor?
Yeah, there is. There is.
I mean, it probably doesn't affect the dipole moment.
I mean,
Well, I think it does, because I think that's what I've been worrying. Like, what's the definition of the dipole moment? I think it's the number in front of cosine theta. We have to sort of be able to write this as. You guys with me? Do you see what I'm thinking of here?
Like we might get like a root 2 out front or something also.
Yeah, like
what you're
something
worried
like
about.
that. Yeah, yeah.
What can we plot? Cosine plus cosine pi over 2
Oh.
minus theta. see what that looks like, and then maybe it'll be like, oh right, that's
Good idea.
of course. You know me in pictures. It's the only way this works for me.
Oh yeah. Felix, did you say like pi over 4? It looks like cosine.
Yeah, I had a feeling it was a pi over 4 phase shift or something.
And
But
then
what's
there
the
should be
shift?
scale
The
as
amplitude's
well.
root 2, isn't it? I think the amplitude's root 2.
Oh, yeah. So this is probably the worst way to numerically approximate something, but okay, yeah, root 2 cosine x minus pi over 4.
Yeah, so there are identities for coming up with that. I
Interesting.
remember learning them in differential equations, right? When you were trying to find the, yeah, like your, I think it was differential equations when I learned that. I know it comes up in physics too when you look at waves. You know, if you got two different things putting waves into a string or something, and with two different frequencies, there's a way to work it out. So do we think that the dipole moment will just be radical 2 QL? So the phase shift doesn't really matter, does it? The pi over 4, the minus pi over 4 doesn't matter, does it? Because we could just define our angle as theta minus, alpha is theta minus pi over 4 is how we're going to define the angle. Does that sound good?
I agree with that. I mean, can you make the argument that that like a difference identity would give you another factor potentially? I guess we get right back here. So never mind. Hey, Bombax. Oh, that's just for when I make a whole bunch of arrows that like make no sense. Which I like to do. I don't think a phase shift would affect it. I agree.
Yeah, I don't think it will either.
Should we check this answer? Does anyone have any objections?
Yeah, sure.
Okay.
Sure, let's check it.
Okay. 620 maybe. Avert your eyes for the other problems. Okay. There's multiple solutions. Oh, look at the figure too. Oh. Looking at them instead of vertical and horizontal dipoles as two diagonal dipoles.
Oh, and then you can add them because now they're parallel. Oh, that's beautiful.
Can you just, well, it is root 2p. So where does the root 2 come from? I think the original
From
dipoles.
that 45-degree angle.
Oh, yes. Because it's L over root 2 for the new length if you treat them diagonally. Huh. Okay, that's why I like checking the answer in the back of the books. That's like so much quicker.
I know,
There's
it's so
an
nice.
interesting one. There's the second solution is interesting too.
Do they do it
They also say-
the hard way? Oh, what?
They also say you can treat the dipole moment as a vector, which I remember learning that in chemistry. Like if you have a little H2O or something, right? It's got a dipole in it, right? Like a water molecule.
I wish they said this
So
in the
and
actual
so if they're
chapter.
vectors, we
Yeah.
can add vectors. Ah, so nice.
Huh. Okay. Well, I mean, if they were each... Oh, yeah, okay. They do get added. Because each one is QL over root 2, and you add those two together, and you... Okay, yeah. And no worries, Bombax. I appreciate you even thinking of it. So what do they do with the second solution? Is this the hard way? It is the hard way.
Is that what we did?
Yeah. It is the same exact like cosine plus sine issue that gives you a root 2 factor. I was just going to ignore those two, to be honest. I'm glad you pointed that out. And theta prime is theta minus 45 degrees. That was a neat problem.
Yeah.
And I guess we've hit just about the 2 hour mark, a little bit over, so maybe we can wrap things up there. If anyone has anything they want to like, or anything to like mention before we go, though, please feel free.
Let's go back to the whiteboard and see who the two smiley face people are shaking hands with each other.
Purcell and Morin.
Oh, it's Purcell and they're giving us the thumbs up, I think, right? Is that what they're doing?
A very big thumbs up. I guess good work. Like the material's really like challenging, but these
I know it
problems
is.
were fun. Yeah,
They're good problems. I feel like I need a bunch of 0.5 star problems to get my teeth into first.
Okay, well, thank you all for hanging out today. I appreciate you.
Thanks for having us, Don.
Yep.
Yeah.
And hopefully I'll see you next week if you're around. All right. Bye.
Yeah. Have a good week, everyone.
Hey, you too.
Yeah.
Okay. Let's switch scenes. Okay. What is under my leg? Oh. It's like the little box that goes to my mic. Okay, so yeah, let's put that microphone up. Okay, so if someone has a question, please feel free to give it in chat now. I don't know, is this oh, someone just boosted the Discord server. Let me see if this person is still around. No worries, $10. If you have any questions about like the push to talk thing is just kind of weird. I don't know why that doesn't work, but if you have a question in general, like let me know. Oh, I need to change my YouTube. I need to change my stream title. Just go into normal math mode. Answering math questions from chat and internet. I never even changed this like title when I did this. I wonder if I should. I just kind of like made it up when I first started streaming, and I never really changed it since. I got all this. No, it's been like a general like math questions now. That's what I'm switching over to. There is one that was in the Discord. It's a calculus one that we need to do.
YouTube live. There. Okay, YouTube's updated. Spacebar. Oh, yeah. I've had that issue too. When I use push talk, I'm just careful about where I'm clicked into because it will mess things up like that. Oh yeah, no, your audio is completely fine. I appreciate you like working on it. Thumb mouse button. Oh, I think I tried that once, my thumb got sore. The cosine, sine, and tan stuff. Oh yeah, SOHCAHTOA is like a lot of people remember, but I don't know, with every math, if you don't use it, you'll lose it. This person provided a translation, which is mark the largest open interval in which f is strictly decreasing. So I quickly did this right before we started up the reading group, and I did get A using Wolfram Alpha. And the answer is A. The person just needs to know how, like, why A is the answer. This, oh yes, I can explain what that means too. We have x cubed over x minus 2 squared. They're being a little bit like fancy. A lot of times people give the same math problem without specifying that part of it. Okay. And so they define the domain and range of the function like that. And so what this like fancy R means, we still just call it R, but it means all real numbers. So it's numbers like 1, 2, 3, negative numbers like -1, -2, -3, 0. Fractions, decimals, irrational numbers like pi, basically every real number you can think of, I guess. But what that /2 means is it's called set subtraction. You're basically taking all real numbers and removing just 2. And they do that because, let me look at chat before I go on. A non-real number is like an imaginary number. Like if you have 1 plus 2i, we'd say that this is a complex number, or in like this is like the imaginary part, and the I comes from like square root of -1 because it's not actually defined. That's like an example of a non-real number. Are there others? Or are they all either real or imaginary? I don't actually know that. Yeah, I guess they're all probably real or imaginary, but you can still have other like kind of stuff like that. Oh, so with variables. The I isn't a variable, it's called the imaginary number, the imaginary unit, or something like that. It's the square root of -1 because we know the square root of 64 is 8 because 8 times 8 is 64. But if you had the square root of -64, you can't name any real numbers that would square to that, because the negative sign like messes things up. But it turns out if you do allow this to exist, you get imaginary numbers. Not a real, yeah. um, so yeah, this function only worries about real numbers. And not only that, it maps real numbers without 2. And so these are the inputs, what the x's are. And it'll take in any real number except for 2 and give you some other real number that may be anything including 2. So like this first part is the input, the x's, and the second part is the output, the f of x. And that's basically saying like what's valid to plug in and what you may get out, or what you can expect to get out. Negative, yes, exactly. It's not normally possible unless you want to allow imaginary numbers. So the square root of negative 64 is actually 8i if you want to allow imaginary numbers, because 8i squared is equal to 8 squared times I squared. 8 squared is 64. I squared is negative 1. So you get negative 64. So you have to have an imaginary number in order to get that square root. Otherwise, it's just not possible. Yeah. No worries. So for this problem, they're interested in the interval for what values of x you put in such that this function is decreasing. And like, what is the interval of those x's? And because they're asking where a function is decreasing, we're going to need some calculus. Where is the problem cutting off? Okay, so I'm sure I don't write underneath what the problem is. In a sense, the I is a variable. Yeah, in a sense. Yeah, you could like think of it like that. It's a variable like a weird rule where when you square it, you get like a real number again, I guess. But yeah, so we have to find the derivative of f of x because we're interested in the rate of change, and that's what the derivative is. And this is a quotient rule, unfortunately. I don't think there's a trick to avoid a quotient rule here. Yeah, depending on like how you scale that I. So to do quotient rule, it's you derive the numerator first. So it's 3x squared times x minus 2 squared minus, now numerator times the original denominator. Oops. Original numerator times the derivative of the denominator times 2x minus 2 over the denominator squared. And we're interested in where this thing is less than 0, because if the derivative is negative, the original function is decreasing. Okay. Let's do some cleaning up on this, though. Okay, immediately cancel an x minus 2 from things. 3x cubed minus 6x minus 2x cubed over x minus 2 cubed, I think. I hope. No. Yes. That's good. Okay. So we get just x cubed minus 6x over x minus 2 cubed is less than 0. I'm gonna have to start erasing this stuff here on the right side. So we have a numerator and denominator that's sometimes positive, sometimes negative. So I think we would split it out into two separate problems, which is one where the numerator is negative and the denominator is positive. And then a second case where the numerator is positive, but the denominator is negative. I think that's the cleanest way I see to go about this. So from this, we would get x times x squared minus 6 less than 0. Does this work the way that I think it does? X less than 0. X, I don't know if this is quite right. Let's just see what we get though. Root 6 is bigger than 2. We might not get anything from this because there's no overlap in these intervals. I don't know if this is quite the right technique here, so let's check the second case and see if we do get the right answer. That should be 36 is the issue. I must have done something wrong. I should not be getting root 6. Actually, no, we should get a solution from 2 to 6. It will be with that red thing, but I made a mistake. I shouldn't be having root 6. Slinger on that. Oh! Sorry, let me catch up on what you just wrote, Bombax. It's just x squared minus 6. Not x cubed minus 6x. I don't see how Sidicon. I might be missing something, but or I certainly am missing something, but I don't see how you get x squared minus 6x. Let me see what Bombax is saying. Even in the same statement, square root of negative 64. I is negative 2 squared. Oh, yeah, there you'd be defining your own new type of complex number, which I think is ultimately, well, it might not be, there might be like gaps in that complex number system that you've created. I think you could create it and like explore math like that. It would be a new type of complex number, I guess. You could define I to be, you know, or I squared to be negative 2. Normally we just always take I squared to be negative 1 or I to be equal to square root of 1, negative 1. If you want to change that definition of I, you're inventing like a new type of math, pretty much, I think. So you're definitely allowed to, but it's not complex numbers as we normally speak of them. Yeah, I mean that can be a Bombax complex, a Bombax number, Bomplex. I don't know. Let me look at Wolfram, just verify my derivative against what Wolfram alpha gets. Because the answer is from 2 to 6. And I nearly have it for my red casework. Yeah, there's like an interesting idea in there. Back. So if you want to make I be minus root 2, that we could look at it like visually. But I want to figure out what the errors in my work. X minus 6 times x squared. The numerator is the same, denominator is the same. Then what's wrong with my technique? I don't get it. Tip to invent some new math. X cubed minus 6x squared. Oh! Sidicon, you're so right. Thank you. Yeah, that was 3x squared times negative 2, and I completely glazed over it. Oh, sorry, and you said I can call you Coco, right? That'll be, and that's far easier for me to pronounce. Okay, cool. We should correct our green work too, because we do need to check that. But we don't get a valid interval from this anyway, which is good. From this, we do get x can be greater than 2 and less than 6 at the same time. So 2 is less than x is less than 6. That's the only interval where the derivative is negative, which means the only interval where x is decreasing. And it's therefore the biggest. Okay. A perfect circle should be easy. Gotta work for a bit. No worries, Bombax. Yeah, squared. So you get with your handwriting? Yeah. And yeah, Femox, I guess I could have checked the critical points too. But all right, let's bang out a perfect circle. This should be easy. But, you know, actually, I think there's actually like a perfect circle drawing like competition, and they have like these weird stretches. I remember some streamer like talking about it. Maybe like the Tutor Wizard or something. That's not bad, I feel like. I wish there was like an app that you could like take a picture of it and it'll tell you how perfect your circle is. I don't think that's, for someone who's not an artist, I don't think that's terrible. Windmill their arms, yeah. Yeah, I need a bigger board to do the full windmill. You win this time. I can give you your points back since that was such like a meme one, but not a bad idea for an app. Yeah, like I can see people like getting competitive about that. Stop? Okay. Oh, I'll take your points. I think it's the exact video. Oh god, that's loud. All right. I took your points. Do the wall and repaint it later? Dude, that is so perfect. What was his arm motion? Yeah, he didn't do... Okay, yeah. So... the bottom is not perfect. Oh, yeah, like a little like lopsided out there, I guess. That's a whole lot better than my circle. Learn to do that. Okay, let's see. Better than my my handwriting has got me in so much trouble in math. Not being able to read my own work or dropping a... like misinterpreting a number. What? Oh, I mean, you're welcome to hang out as long as you want, Bombax, but if you're out of here, then I'll see you around. That's crazy. Then the sound is kind of satisfying. It's almost like a zipper. Oh, is the chalk the chalk shaped? That's a tongue twister. Chalk shape. No, maybe it's not. I just can't speak. I love the subtitles too. Try it with a marker. Dirt, bur, zert, dirt, bur. This is more of a dir than a burr. So I'm gonna have fun with those. It's the chalk pointing forward. Huh. 67 million views. Oh my god. Okay, let's type out a response to the person who asked this question, because I don't think they're able to stick around. They were here earlier in the stream, but I assume they had to leave. So let's here's what I did. Since they're asking about intervals of decreasing, or, you know, if x decreases, let's find where the derivative is negative. Using quotient rule, f prime x equals slash frac. I guess I'll write out the first step of the quotient rule. Squared minus x cubed. How do you do multiplication? Tutorial on the... okay. Is it slash mult? I think it's slash mult. 2x minus 2. I should probably put a space there in case the LaTeX hates me. The denominator is x minus 2 to the 4. Let's do... what was it? Which slash is it? Slash slash? I think it's that slash slash. I guess we'll find out the hard way. I just want a new line there. Slash frac x cubed minus 6x squared over x minus 2 cubed. Let's just check that. Compile error. Yep, it's the wrong slash. Compile error. Is it? Oh, it's the slash mult? Oh, slash times. I bet you. There we go. Then, where f prime x, I mean, I guess I should put this all into one comment so it's all the same LaTeX block. Then figure out where f prime x less than 0. This can happen either when x cubed minus 6x squared less than 0. Which one do I do first? Okay, yeah. And x minus 2 cubed greater than 0. Or when these same things but flipped. Solving the first pair of inequalities. The only valid interval we get is from the first inequality where x is greater than 2 and x is less than 6. So our interval is 2, 6. Okay. Can't ignore this. I spent points. Try the dotted line technique through the circle with your marker. Okay. The first pair of inequalities. This poor bot is working overtime, dealing with my crappy LaTeX skills. You know, clearly this is going to have to work with a whiteboard, right? Not, I get to hit dislike on the YouTube video. That's how that works. Oh, you just have it like face first on there, and it just skips on its own. Wait, is this noise actually in sync with the music? It just sounds like noise and music put together to me. I'm pretty sure he just puts the marker face, or the chalk like face first onto the board. You can't ignore this. I spent points. Try the dotted line technique with your marker. All right. As far as I can tell, he just goes right for it. Is that what you wanted, Astro? Let me, can I... Yeah. Ta-da! Definitely works with a marker. Try more pressure. I think I threw out my bad markers. Do I still have them? Perfect. Oh, good. Yeah, I threw away my bad markers. I'm taking those points too. You tried? You know, I appreciate the moral support there. Okay, so I think that's the end of the questions that are from my Discord. We could take a look around. I guess on Reddit. I think I'm gonna have more success with the math Discord if I want a random question. Let's try the math Discord. Did I size this? Okay, yeah, I sized it fine. I have so many pings on Discord. Something weird. I assume that's cotangent. Oh, it's in Spanish. Oh, okay. It's interesting. Oh, and wait. What is tangent in Spanish? What? T-O-K? Oh, that makes more sense. I was like, there's no way that Spanish uses a K there, right? That it is composition. Okay, okay, never mind. According to the following functions for K of X and T of X. K and T are still weird functions to use, but... So they want K of T of 2 for the first one. So you start by getting... Oh, wait, is this the weird thing where it flips with this stupid dot notation or circle notation? You start with doing T of 2, which is 4, and then you do K of 4, which is 8? Or is it flipped and you do K of 2 first? I don't remember this, to be honest. Because I feel like I've heard that it gets flipped, or I think the first T of X? Okay. Well, you go right to left like you did the first time. Okay, good. I felt like for some reason the abstract algebra book defined it reversed, and I was super confused. I like to rewrite these problems in a different form. That's more clear to me. Taking the first problem as an example. K slash circ T of 2. Oh, we need parentheses around those. Is equal to K of T of 2. Oh, no dollar sign there. This means we start by finding what T of 2 is, then plug the result into K. So K of T of 2 equals K of 4 equals 8. The other problems can be solved the same way. Let's make sure the LaTeX works. Hey, I actually did LaTeX right in the first try. It's a miracle. Let's see if they get back. That one's actively being worked on. What's happening here? This looks like physics. Because I just see M's and that makes me think of mass. That's all the reason why I think it's physics. It's actually not. What's the question? What are valid values for M? Do you have a function R of X defined for all X between 0 and 3? And where is R prime X less than between -1 and 1? Is that an 8? I don't feel like I understand what's happening with this one. I don't know economics. Y squared is less than Z. Less than or equal to Z is less than or equal to 2x. That's a weird... What? I think I understand what they're trying to say with that. That's a weird way to present it to me. Okay, so on the volume of the region bounded by, I guess, these curves, though. This technique, it kind of makes no sense to me. I want to figure out if I can figure out the problem like the way that I would think of it and then reverse engineer. Actually, what's their question? How do they know y squared is less than or equal to z less than or equal to 2x? So, okay, z equals 2x is a plane that goes through the origin. It goes through the xz axis. Z is also y squared. That's a funny like rotation thing. Okay, I kind of want to draw this for myself. They provided a graph, but I get a better intuitive understanding of how this works if I draw it myself. X, Y, Z. We want the region bounded by Z equals 2x. Z equals y squared. And x equals 3. Okay, so Z equals 2x. I don't know how to draw this. I can see it in my head. I don't know how to draw though. Basically, in the xz plane, you would draw the line just to x, and you would extend a plane. You would extend it for all y values. If y is coming out of the board, I guess it would. It's a plane like that, I guess. I should be tilted more up. I drew a 45-degree angle again, like Stuki said. And we also have a vertical plane. Well, vertical is a tricky word here, but like x equals 3, we draw the line x equals 3. So we have like a triangle. I drew this so terribly, dude. We have like this forms like a triangle tunnel almost. But we also have z equals y squared, which is, if we look at just the zy plane, is like a parabola. But it's true for all x, so this thing gets rotated around. So we have, that looks like a bowl, and we want to take like a quarter of that bowl, I guess. This is, I think a little more helpful visualization here is just boiling it down to the xc plane. Wait, no. It does not get rotated. It gets projected. It's like an infinitely long trough, this parabola. Because a rotated bowl is z equals x squared plus y squared. But that's not how that works. Or, you know, that's not how this thing works. You get the exact same parabola, but shifted down every possible value of x. So it makes more like a trough. Either way, we can look at just the level curve in the xc. Oh, can we do that then? How does that work? I was visualizing this wrong before. Yeah, you're right, Fetbox. You caught up before. Before I did. In Coco, x equals 2z and x equals 3. Wait, x equals 2z? No, z equals 2x. And we'll go back at the problem. So, do we need to instead look at the yz plane and take x equals 3? How would that look? No. You know, that I can't make a helpful two-dimensional impression. That's usually how I try to think about these. This one, it's kind of tricky though. It makes sense to me that the parabola should go below this line. That's completely intuition though, not an actual explanation. So let's look at actually the graph they put, like the graph that they posted. I want to make my own so I can rotate it around. I love that animation, by the way. What? Z equals y squared. Okay, so that's just hard to visualize. Yeah, this one, it's specifically like just not simple. I think yeah, Desmos is really helpful here. I think your only bet here is to think about how the bottom of this parabola, like the bottom of this trough, goes with z equals 0. And this plane is generally going to have a positive z value for the region that's being bounded. Does that make sense what I just said? When y equals 0, y is along there, yeah. So wait, can I make a two-dimensional impression with y equals 0? Yeah, so we want, yeah, below the right plane above the, like, that bit inside there, I guess. It's kind of hard to say, but... No, even if I take y equals 0, you can't really... Can I? No. So I think what I want to say is that I would typically do this by looking at like level curves along like one of the xy, yz, xz planes, but this one kind of beats that as far as I can figure. So the next best choice is visualizing it three-dimensionally and thinking about your z values, because we have two different functions for z. Intersecting with vertical planes, x equals a constant. Well, then how do I draw... How do I draw, like, where I get stuck with that is, how do I draw z equals 2x? That's what was beating me every time when I tried to do that. So you'll go from 0 to 2 constant. A vertical line. That might be a nice way of saying it. If we take x equals 1 and we look at the yz plane, we get z equals y squared. That's easy to draw. And if x equals 1, z equals 2. It doesn't need to be a dotted line. Funny. I guess that's your two-dimensional drawing. Okay, nice call there, Finbox. Instead, take x equals 1 and draw what the YZ plane should look like. You have the parabola y equals z squared, and a line z equals 2. Because z equals 2x. This is your indication that the trough formed by y equals z squared we want to start by bounding z, since there's two functions involving z. No, that I think the person knows that part. Y equals z squared is below c equals 2x in terms, z equals y squared, their respective z values. Fundamentally, we should know that z equals 2x and x equals 3 form planes, and that z equals y squared forms a trough with parabola for the sides. Just need to check that it's true from that it stays true for x equals 0 all the way through x equals 3. Which it does, right? Because 6 is not more than 9. Do these... Oh, what? Wait. I'm thinking about this wrong still. Do I get add x equals 3? The region inside these two curves is bounded below by the parabola and above by the horizontal line formed by z equals 2x. We can also at x equals 0, the parabola is a single point? I don't think that's true. Or what do you mean? Or maybe I'm misinterpreting you. At x equals 0, our horizontal line shifts all the way down to the bottom of the parabola. Oh, okay. Oh, I see what you mean. Yeah. At x equals 0, or horizontal, or the parabola stays the same. At x equals 0. Z goes from y squared to 2x, yes. Now this solution does x next, which seems weird. Doesn't y just go from 0 to 9? No. Y goes from 0. If x equals 3, z equals 6. If z equals 6, y equals root 6, plus or minus. Uh, maybe we don't need to go to x equals. Where is our x ranging from? Dude, this is so tricky. I might delete this x equals 0 bit here. The how do we bound our x? Why does x not just go from 0 to 3? I'm kind of confused by that. I really love triple integrals and visualizing them. I really actually enjoy this part of calculus, but this one is just so tricky. They're definitely not easy, but I do enjoy the puzzle that these types of problems like pose, I guess. Yeah. I'm having trouble with Desmos, to be honest. So x is going from the plane. That's the trick. X goes from the plane up to 3. We've already integrated in terms of z. So we need to say, remember that z equals y squared? That's crazy. In another integration order, if we integrated x first, we'd simply say that x goes from the plane, x equals 2z, or z equals 2x. Yeah, Zach. This person in the math Discord is trying to get an explanation for the volume bounded by these functions goes with this integral. And I think I've done a lot of reverse engineering here. I really enjoy these problems. This is a really tricky one. The functions look simple, but we've had a lot of back and forth here figuring out why these bounds are the way that they are. I was having a really hard time drawing level curves that were helpful, because that's only how I do these. The first ones that I tried were not a lot helpful. From the plane z equals 2x to 3. But we've already used z. We've already used z. So we have to remember that I don't know, that's some bad phrasing, but we're integrating with z first. So let's substitute z equals y squared and say that y squared equals 2x. So x equals, Are they multiplying by 2 and taking advantage of symmetry here, or what's happening? No, never mind. You don't have to worry about that. Sorry, I don't know why I was square rooting. Y squared over 2. What? Oh, I didn't mean to do that. Y squared over 2. That was the lower bound. Yeah. Okay. The last problem, why does y go from minus root 6 to positive root 6? That's because z goes from 0, no, oh. Yeah, okay. That's a weird thing with the square roots. Z goes from 0 to 6, but if we take 6 equals y squared, we get plus or minus root 6. We can't just go from 0 up to root 6. Okay. We have to notice that z ranges from 0 to 6. Parabola, we get 6 equals y squared. So z equals plus or minus square root 6. Y equals that. Okay. It's a fun problem. Kind of a journey, though. Who was the person? Oh, you know what? Thank you, Hardlocked. Second best beard on Twitch. Oh my god, you started streaming again. There's even more competition now. I need to look at your VOD. I've been playing with you each time that you stream, just unless I missed one, so... I need to see how you look now. Where's the person that I was living before? Did they get what they needed? Okay, yeah. Steam is inclined 70 degrees from the horizontal, rises 3,000 to vertical feet. I gotta draw this, or we can look at their drawing. Eight hundred 70 feet from the base of the mountain. I think these are... ...3,000 vertical feet. Wait, 3,900? I don't know why they wrote 3,900 vertical feet. From the base of the mountain. Does the base of the mountain mean the bottom center or the bottom edge? Does it matter? Maybe it does. No, it should matter. The bottom edge? Okay. Yeah, I guess you're right. I think I need to make a new drawing for this person. I'm gonna do it in Paint, so I'm too lazy to get a screenshot of the stream right now. Where's Paint? Copy, paste. $3,000. $70. Let's do a different color. I guess green. And so the idea of this problem is we know the bottom of this triangle. We can use trig to figure out the side of this triangle. And we can use geometry to find out this angle. And then law of cosines can be applied. Okay. It's definitely not 3008.24 feet. I can only assume that's a chat GPT answer or whatever AI you're using. Because if this vertical height is 3,000, there's no way this length over here is going to be 3008. Work out another side and another angle in the green triangle and apply law of cosines. Really thinks it's 3008? It's not. Did I shoot? Wait, I think I lost track of time. Okay, no, I'm good. I'm good. I thought I might have had to like do something else today, but I don't actually. All right, just in the spirit of proving chat GPT wrong. One of the people I was just playing with Central sent me a conversation with ChatGPT where it was insisting that strawberry has 2 R's in it rather than 3 R's. Like over and over, asking it multiple times, correcting it. ChatGPT was still like, no, 2 R's. But we want 3,000. No, we want opposite. Sine of 70 is opposite over hypotenuse. If we want the hypotenuse, we do 3,000 divided by sine of 70, right? 3,000 divided by sine, and that's less than 1, which will increase. Okay, good. Yeah, the hypotenuse of the mountain is already 391.5, we'll say. So that green line is definitely going to be bigger. But I'm following through with this just because I like, proving AI wrong. Oh. That would get you, I think, the adjacent side down there. And then using geometry. This angle is 180 minus 70 is 120. Now we can mob cosines this. I guess we'll need that. So the remaining side equals the square root of the other 2 sides squared. 870 was the other side. Minus 2 times each of the other sides. Times 870 times cosine of 110, 120. $37.04. What? Why is that secant? 110 is right? Oh, I can't do math. But why is it changing it to secant? What? Oh, was it giving a common denominator? Why would you do that to yourself, Wolfram? $35.84. Oh, do you not know the majesty of Wolfram Alpha? It's amazing for anything with math. And they don't have a stupid language AI on top of that. Now, if you could integrate a language AI with Wolfram Alpha, you might be talking. I don't get why Wolfram Alpha is doing this stuff, but I trust the final result. It's interpreting the input, right? Might be able to, or something. Like, let the AI handle the language and Wolfram do the actual math. That'd be, probably a pretty good combo. Wolfram's probably going to charge you, though. Track the 70 from 180. Yes. That's what I did, too. Okay, I don't want to go for another math problem right now. I do want to Okay, cool. I assume this person, it's been a while since they last had to do anything with this thread, so it might be a while before they see that. I think I'm gonna wrap things up there for the day. It's been a fun day, but also a long day. Okay. Yeah, so I'll have the stream here. If you're here on YouTube, I appreciate you. I'll be back Tuesday. So goodbye, YouTube.